Hi everyone, my name is Jappn and today I'll be performing the traffic lights demonstration. I have our management team behind the camera and they'll be taking care of any questions you guys have. So be sure to put your questions in the Q&A tab. Also, throughout my demonstration, I have some e-poll questions. And my partner Selena will be behind the camera and reading those out to you guys. So let's get started. So in front of me here, I have an earthenware flask with about 20 milliliters of water. So what I'm going to do is I'm going to add in a few drops of indigo carmine. So some background information on indigo carmine. It's a chemical indicator. So a chemical indicator is a substance that changes color with different pHs. So just detects how basic or acidic a solution is. And note that basic solutions have very high pHs, so pHs around 8, 9, 10, and above. And acidic solutions have very low pH, so pHs around 1, 2, 3. So now I'm going to put in a few drops of indigo carmine. And this compound is a blue color. So when I add it to my solution is also going to turn blue. So here's my flask, and when I swirl it around, we can see that it's a blue color. Next, I'm going to add in some hot sodium hydroxide. Sodium hydroxide is a very strong base, which means it has a very high pH, so a pH around 11. So now I'm going to take the sodium hydroxide, which I have in this beaker here, and I'm going to pour it into my earthenware flask. And we can see what happens to the color of the solution. So when I add the sodium hydroxide to the solution, it turns a green color. Next, I'm going to add some D-glucose to the flask. D-glucose is a sugar. So now I have an e-poll question for you guys.
So our first question is, what do you think will happen when Jappn solution? A, an explosion. B, the color will change. C, bubbles will form. D, nothing will happen.
So right now, a lot of people are voting for a color change. So be sure to quickly lock in your answers. So we have about 30 seconds left on the e-poll. And so far, color change is winning. Okay, so color change was the one with the most votes. So let's see what happens. So I'm going to add about 10 milliliters of glucose to the flask. So now I'm just going to add the glucose. And I'm going to swirl the solution of it. If you guys look closely, you can see that the color became a little bit more yellow. And now it's turning red. And now it's very, very yellow. So adding the glucose caused a color change. Next, and now I'm going to swirl the flask and we can see what happens. So when I swirl the flask, if you look closely, you can see that traces of red can be seen. Next, I'm going to shake the flask. But before I do that, I have another e-poll question for you guys.
So, what color do you think the solution will turn when the flask is shaken really fast? A, blue. B, green. C, red. Or D, yellow.
So right now, blue and red are in the lead. So there's 30 more seconds for the E poll. And so far, red and blue are still in the lead, but green and yellow also have some votes. Okay, so red won. Let's see what happens. So first, I'm going to use my hand as a stopper to shake the flask, and next I'll stopper it with this stopper, and then we can see what happens. So when I put my hand on top of the flask and shake it, we can see that the solution turned green. And now if I just leave it to be, we can see that it turns back red and then back to yellow. Now I'm going to stopper the flask, and then we can see if it makes a difference. So now I'm going to shake the flask again. We can see that it turned green. And when I let the flask sit for a little bit, it should change back to red and then back to yellow. But because the flask is stoppered, it stays at the green color longer. And then it turns to red and then to yellow. So what's happening here? So like I mentioned before, indigo carmine is an indicator. So I have another e-poll question for you guys.
So, what do you guys think a chemical indicator is? A chemical that changes color at different pHs. B, a drink. C, an organism or species that show the presence of specific environmental conditions. Or D, Jappn's finger.
So far, the first option is winning. So it's a chemical that changes color at different pHs. So we have about 30 more seconds. And a lot of people are voting for the first option. Yeah, so you guys are correct. An indicator is a chemical that changes color at different pHs. So when we first added the indigo carmine to the water, it was a blue color. And then when we added sodium hydroxide, it changed to a green color. So sodium hydroxide is a very strong base. Based off that information, I have another e-poll question for you guys.
If sodium hydroxide is a strong base, what pH do you think it has? A, 0, B, 3, C, 7, or D, 12?
So far, there's a lot of votes in for 12. So there's about 30 more seconds, so be sure to lock in your vote. Okay, so you guys, majority of you guys chose 12. And you guys are correct. So sodium hydroxide, because it's a strong base, it's going to have a very high pH. So indigo carmine, when it encounters a strong base around the pH of 11 and 12, it changes to a green color. And this is because indigo carmine becomes oxidized. So oxidation is when a compound loses its electrons. So electrons are these teeny tiny negatively charged particles. So when we added in that sodium hydroxide, indigo carmine became oxidized and turned green. Then when we added in glucose, glucose is a sugar and it reduces indigo carmine. So indigo carmine became the yellow color. Now, when I lightly swirl the flask, it turns red. And you can see traces of red in it. And this is because in the air, we have oxygen. And oxygen oxidizes the indigo carmine, so you see that color change. And the reason you're seeing red is because only some of the indigo carmine particles are being oxidized. So we get a mixture of the red and the yellow and the green color. On the other hand, when I shake the flask, it turns green. And this is because a lot of oxygen is able to be dissolved in the flask, So all the indigo carmine becomes oxidized and the solution becomes a green color. And then when I let it sit for a bit, the oxygen comes out of the solution, so the indigo carmine is reduced again, and we get the original yellow color. So that's it for my demonstration, guys. Thank you for listening. I hope you guys enjoyed it, and now I can take any questions.
So we got one question right here. Someone wants to know, is this mixture edible?
So this is not edible. It contains a very, very strong base, sodium hydroxide. And strong bases can damage your body, so you should never drink this solution.
We have no other questions right now. Oh, yeah, we're good. What can you do to get the blue color again?
So you can't get the blue color again because we added in the strong base, sodium hydroxide. And the sodium hydroxide causes the solution to become basic. So remember, since indigo carmine is an indicator, it's going to change colors depending on if the solution is acidic or basic. So if we wanted to get the original color back, we would just have to make a new solution with some new indigo carmine.
Awesome. Someone else wants to know, why was this demo called traffic lights?
So this demonstration was called traffic lights because the 3 color changes correspond to the 3 different traffic lights. So we have the yellow color, we have the green color, and we have the red color.
Perfect. We have one more question here. Someone is asking, what are indicators made of?
So indicators are just made of compounds usually that we find in nature, and a lot of the times they're organic compounds. So they have a very complex structure. So indigo carmine is just one example.
Perfect, thank you. It doesn't look like we have any questions left.
Okay, so thanks again guys for watching. I hope you enjoyed, and be sure to stick around for the rest of the demonstrations today.